Section 5.2, number 4, we've got a binomial experiment with n trials, and the probability of success on a single trial is 0.2. We're going to round our answers to 3 decimal places. Find the probability that r is equal to 0. In part A, we want to find the probability that r equals 0. R is the number of successes. And I got this big, thick pencil that I can't seem to fix. Well, we'll go with it. Now, we have a formula that says the probability that x, the random variable, is equal to r, where r is the number of successes that you want, is given by this. It's n, choose r, the number of trials, number of successes, that combination, times p, the probability of success on a single trial, raised to the number of trials, times q, which is 1 minus p, to n minus r, the number of failures. So what do we have here? We want the probability that, say, x is 0. This is going to be, out of 6 trials, right, n is equal to 6, choose 0. Out of 6 trials, no successes, times, now the probability of success on a single trial was 0.20. 0.20, and we want 0 successes. Probability of failure is going to be 0.80, right? 20 and 80 have to add to 1. And this is raised to the number of failures. Well, if we have 6 trials and no successes, we must want 6 failures. And now if we do this completely by hand, we will have this, all right? We need to get this right here. All right, so to get that one, we will take 6 factorial on top, right? It's a combination. So you have the total number that you have on top, factorial, and on the bottom you have the number of successes that you want, 0 successes, times the number of failures, 6 minus the number that you don't want. All right, and then what is this right here? What is 0.20 to the 0? Well, a non-zero number to the 0 power is 1, so that's just going to be a 1 times, and then we'll do this one. 0.80 to the 6th. All right, but what do we get over here? See what happens here? That's just 1, right? 0 factorial is 1. 6 minus 0 is 0. 6 minus 0 is 6. 6 factorial divided by 6 factorial is 1. So what we're looking at is 1 times 0.80 to the 6th. So get your calculator, 0.8 to the 6th. I got this to be equal to 0.262144, but we want to round it to 3 decimal places. So 1, 2, 3. That digit is below a 5, so I'm going to claim this as 0.262. All right, that's what I'm going with. And I guess we're supposed to write it up here at the top. In part A, 0.262. In part B, what we want now is what's the probability that r is greater than or equal to 1? All right, now what that means is this. What is the probability that the number of successes is 1 or more? So it could be what? 1 or 2 or 3 or 4 or 5 or 6. All right, now, when you see something like this, where you have a greater than or equal to, at least think the opposite. All right, so you want to think opposite. So as soon as I see that, I'm going to think opposite. But as soon as I say think opposite, then the opposite is going to be 1 minus, all right, well, what's the opposite of 1 or more? That's just going to be 0, which we just happen to have found, 1 minus 0.262, which is 0.738. So I'll put that up here, 0.738.